Hi, I'm Glenn Burden from the Maker Hive, and today I want to talk to you about the Yellow Jacket pick and distribution block made by Yellow Jacket Concepts. It's pretty much like any other distribution block. You got pass through from this point to that point, and the next one to the next one, so on and so forth, just like any screw terminal type block. Except you notice in the center here there's a row of jumpers, and you can do some pretty unique things with these, and I'm going to demonstrate that here. Okay, this is my printer, and as you can see it's printing right now, but I want to be able to hook up these little fans on my print bed around, so I can move them around, set them wherever I want to for cooling different types of parts. And I want to control them with these little fan speed controllers. It's just a PWM output, hot and ground in, motor controls out. And I'm going to mount everything over here. If I turn my printer carefully, I have a panel here that opens up where I can get 12 volt power off of my main board, and I'm going to mount these speed controllers in this panel here, so the knobs are outside here, so I can control the fan speeds for each fan individually. And I'm going to use that using the YJ pads to connect everything up, and it'll be a lot cleaner looking. I won't have all this kind of mess with just wires hanging and wire nuts or whatever. And instead of doing it here on the printer itself right now, I'm going to go ahead and do it on the bench, just so you can see more clearly what's going on. And these can be mounted in several different ways. You can use standoffs like this one has. The grooves in the ends are for a 3mm screw, or you'll be able to 3D print a holder for them that can be screwed to a panel, double-sided tape stuck down. And the way these work is you put this in like this, and it snaps right in just like that. Okay, I blew up the schematic for the distribution block rather large here, so I can demonstrate and show what's exactly happening. Like any normal distribution block, you have your inputs and outputs are connected straight across, just like any barrier strip or power distribution. What makes this unique is the header pins in the center. Because if I have power coming in on one block, I only have one output. So for my project here, I'm going to need 4 outputs. I could tie them all together and put them into the one end, but if something goes wrong and one of the motor speed controllers burn out, I have to unwire all 4 of them, untwist the wiring, twist a new one in, get it all hooked back together. I prefer to have 4 outputs, one for each motor speed controller, and I can do that rather easily. Instead of making jumpers like you do with normal distribution blocks, you have to jump one block to the next to get power coming out the other side. I can simply add a jumper block right across these 2 pins, and now I have one place to bring my power in, 1, 2, 3 outputs. And if I add a second jumper block here, I now have my one power coming in and 1, 2, 3, 4, 5 outputs. The other unique thing about these blocks is they're not screw terminals. They're a spring cage. You just push this tab down, insert the wire into the hole, and release the tab, and that holds the wire in there pretty good. In my line of work with the RV industry, I can assure you that screw terminals of all shapes and sizes, no matter how well they're torqued, will come loose. Unique thing about spring cages, because the spring is constant tension on that wire that's through the spring, so vibration can only tighten that spring, it can't loosen it. And this is a pretty heavy board, and I bounce it up and down quite a bit and it's not coming loose. Okay, what I'm going to do with this project is I'm going to bring power in on this point here, so this will be my positive input, and instead of using just a jumper here like I described earlier, I'm going to use a switch. So I'll connect a switch here and remote it out onto my panel, which you'll see in a minute. So my switch will be here, so now I have a switched positive input, and then I will add a jumper block here to connect this strip. So now I have a positive output for fan 1 and a positive output for fan 2, a positive output for fan 3, and a positive output for fan 4. And those will all feed power to all my motor speed controllers for the fans. I took a just a regular mechanical on-off switch, wired 2 wires to it, put a Molex 0.1 connector on the end, and I will put that on my first jumper block instead of a regular jumper. So now what that does is gives me an on-off switch to power up the block 2 that's next to it. So all we have to do is add a jumper right next to my switch. Let's get this out of the way for a minute. So now I will have a switched input and powering up 4 outputs all at the same time, and no jumper wires, nice and clean looking, and easy to modify later too. Next I will connect my ground wire to this point, and again, instead of just jumping here to send ground to everything, I want to fuse it. This is that way if something happens, goes wrong, motor speed controller shorts out, burns up, whatever, I don't damage this in any way and melt wires or anything like that. So what I'm going to use is a PTC fuse, which is just a small fuse that you'll see in a minute, and connect it here. So I'll have a fuse on my ground side, and now I have 2 grounded fused outputs here. I'll add another jumper block across these pins. That'll give me 4 ground outputs, 1 for each motor speed controller. One more thing I want to do to this, I want to add a power on indicator LED, and I can very easily do that without unwiring anything. All I have to do is plug a LED into these 2 blocks right here, because this one's positive, this one's ground. I can remote out a LED right like that, and now I have a power indicator. Okay, for the motor speed controller outputs, I'll use a second YJ pad, and each motor speed controller has a positive and negative on its output to control the fans. So I'll make this fan 1 positive and negative here. I'll make this fan 2 positive negative. Down here I'll make this fan 3 positive and negative, and this one fan 4, just like that. Now I could just connect my positive and ground for each fan in here and over here, but instead I put pin header connectors on the ends of the fan. So all I have to do is plug this fan 1 in here, plug fan 2 in here, plug fan 3 here, and fan 4 here. And it makes it real easy, because if a fan burns up gets damaged and I need to replace it, all I have to do is unplug it, plug a new one in. If a fan speed controller fails and it's no longer controlling this fan, I just unplug it from here and I can plug it in right here and use fan 3 to control two fans at the same time. Okay, here on my printer you can see that I've installed the two YJ pads, the 4 motor speed controllers. This is what it looks on the outside of the printer. I can turn on my fans right here, control their speeds, and shut everything off at once with the on-off switch. Okay, so when I turn on the switch, the little LED comes on and shows that I have power to the system. You can see here that this switch just has a pin header connector on it, 2 position, plugs right in. Here I have the LED. This is a 12 volt LED. It has a built-in resistor, so all I had to do is put it in a pin header connector. This is the PTC fuse. Again, just connected to a pin header connector. And then you can see the 2 little yellow jumpers to complete everything. The outputs from the motor speed controllers down here for the fans. Fans are just plugged in across the positive, negative for each output. After I got this all done, I decided I want to add this little voltmeter. I may cut a hole and put it out the face of this panel. But again, just with a 0.1 connector on there, I can just simply plug this in to where my LED's plugged in right next to it, because there's it's a dual header row. And it shows my voltage. And of course it all turns off with the switch as well. Here's one of the fans that I connected to the system. It's a little fan holder I printed. I'll put the STL up sometime for that. But as you can see, the fans spin up here with the speed controller. That's full speed, and I can turn it way down. If you get right down to the bottom of the speed controller, the fan stops. But the one thing I like about this setup is I can set my fan speeds to wherever I want them. Let's say I got this one full speed, this one low speed, and these two somewhere in the middle for printing certain objects. And if I'm going to be printing the same object again tomorrow and don't want to adjust my fans, I don't want to turn them all off individually and then have to find that sweet spot again. I just shut them all off at once. Okay, that's the YJ pad from Yellow Jacket Concepts. Again, these are very versatile tools. They work great for just about anything, robotics, stepper motor connections. You can change stepper motors real easy. You can bring them in from your stepper motor controller here and just plug your stepper motor right into that. They work great for testing things too. You don't have to do a bunch of unwiring. You can just put your meter probes right onto the pins and measure voltages and signals. You don't have to try and get your meter probe in there or pull the wire out slightly or anything like that. They're just an all-around very versatile tool. Again, my name is Glenn Burden. I'm from the Maker Hive, and reminding you to be inspired, be creative, and be a maker.